Hey there. All right, I'm going to start with a couple review problems from yesterday. We were doing area of a regular polygon. The area formula we're using, 1/2 the apothem times the perimeter. But we found yesterday that we have to do some special right triangle stuff sometimes to get all that information to be able to do the formula. Okay, so when I look at this particular example, it's a hexagon. They've given me a side length is 14. All right, that's probably going to help me find the perimeter, but I'm going to have to work on finding the apothem. So let's do that. Let's drop the apothem. Remember that comes perpendicular straight down to the side, creates a nice little right angle. And then we also draw in a radius. And we learned yesterday, and you have it in your notes, that in a hexagon, when you drop the radius and the apothem, this is a 30-degree angle. And a 90, so we've got ourselves a 30, 60, 90 triangle. And when I look at my 30, 60, 90 triangle, if it helps you, you can pull it out of there so you can kind of write on it a little bit better. It's up to you. But what I know is that since this whole side here is 14, then this little short leg would be 7. This piece right here would be 7. Okay, now what I really want is the apothem, which is this long leg. And from our 30, 60, 90s, if the short leg is 7, then the long leg is 7√3. All right, that happens to be the apothem then, 7√3. So then we can go up here and let's do our formula. A equals 1/2. The apothem we just found to be 7√3, and our perimeter, since one side is 14 and we have 6 sides, you would take 6 times 14 and get 84 for that. All right, now typically they're going to probably be asking for this in decimals, so let's go ahead and just type it in our calculator. I'm going to type a 0.5 times 7 times the square root of 3 and then times the 84. You might have to be sure that you close your parentheses after that square root of 3, or what I sometimes do is I just do the square root of 3 at the very end, and I'd put the, because I'm just multiplying, the order I multiply doesn't matter, so I could put the 84 earlier. All right, so what do you think the area should be? I got 509.2. All right, now let's try another one. All right, from yesterday, what do we have here? This is kind of a weird one because actually I was going to throw something new at you a little bit here. It's using what we know about 45, 90s because this is a square, and when you drop that angle, that's a 45, 90. Now you can do other formulas. We've been doing 1/2 AP, but really the way I see this set up, if the whole square there would ultimately just be a base times height kind of formula. That's what we used like in the very first lesson, but the base and the height in a square happen to be the same. We have to figure out what they are. So you have yourself a 45, 90 where the hypotenuse is 30. All right, so in a 45, 90, it looks like this. So the two sides are x, they're the same, and the hypotenuse is x√2. All right, so what do you think we need to do with that 30? Okay, we should be taking that 30, since we're going from the hypotenuse to the short leg, to the leg, we're going smaller, we need to divide by √2. So I'm going to take 30, I'm going to divide it by √2. And then I'm going to rationalize it. I get 30 √2 all over 2, and then the 30 and 2 can reduce to just a 15 √2. Oops, 15 √2. All right, so what we just found were the two legs, which happen to be, if this is 15 √2, and this down here is 15 √2, we just found the base and the height. So we don't have to use the 1/2 AP, we still might have these special right triangles in there. Why don't you go ahead and tell me, what do you get for the area on this? Should have 15 √2 times 15 √2. Now you can kind of maybe just do a little bit in your head to make your life a little bit simpler. remember, I'm just multiplying here. The order I multiply things does not matter, but this root 2 times another root 2 should be 2. So I'm just going to type in my calculator, 15 times 15 times 2. Now you can do the root 2 business if you must, but I thought it would be easier. So I have an area of 450. So that was a review of some special right triangle stuff. Let's move on to some new stuff. Okay, so on this one, we have ourselves a pentagon. We haven't done any pentagons yet. So I'm going to go back to my 1/2 AP for a regular polygon. And I have to figure out what kind of triangle I have. So is it a 30, 60, 90? Is it a 45, 45, 90? So let's go back to the early part of yesterday. What we would do is we'd draw on these 2 radii, and really what we were doing is like kind of drawing all of these in, and whoa, that's a crazy one. Okay, and we'd see, oh, there's 5 triangles. So my question is, what's this angle measurement right here going to be? All right, so declutter some of that, but find that. Well, that's just 360 and divided by 5, and I get a 72. Okay, so that central angle there is 72, but remember, I still need to drop the apothem. When I drop the apothem, that 72 gets divided by 2, and so now what I have is a 36-degree angle. Well, if that's 36 degrees, I don't have a 30, 60, 90 or a 45, 45, 90. This is something else entirely. This is something I'm going to have to use SOHCAHTOA on because it's not a special right triangle. So let's look at what we want out of this. I'm kind of redrawing. So I'm going to take this triangle right here that I had, and I redrew it down here. That's my right triangle. So let's work on that. What do I need out of that? Well, I know I need the apothem. So that's this leg right here. That's the apothem. I'm going to look for that. I am given the hypotenuse over here. That's 10. And I know that this is a 36 degrees. So from the 36 degrees, I know the 10, that's the hypotenuse, because here's my right angle. And I'm looking for the A, that's adjacent to the 36. Which trig ratio do you think we need to use? Okay. Hopefully you're thinking, oh, maybe I should write it here for us. It's SOHCAHTOA. If you're using adjacent and hypotenuse, you should be using cosine. So we would set up this problem. Cosine of our angle is equal to the adjacent over the hypotenuse. Okay, this is the easy one that you just get to multiply both sides times 10, and you'll have the A solved. What do you think A would equal? All right, so I'm just going to type in my calculator, cosine of 36, and multiply it by the 10. Maybe put the 10 first. I got an 8.09. Now remember that you kind of want to keep a few more decimal places than what they're asking for, and don't round entirely until the very end. Okay, so now I know the apothem. So if I go up here, I'm going to be able to plug that in for the A value. All right, let's try again. We still need to find the perimeter. So the perimeter, I'm going to have to know the side lengths, which makes me think I'm going to need to know this measurement then. All right, so let's try again. I'm going to redraw that triangle. I'm going to do it again here. I've got the 10 still. I'm going to use that. I know that this is a 36, but what I'm looking for this time is this side down here. Let's see if we can find that side. Okay, so based on that, do you think you should use sine, cosine, or tangent? Right? Hopefully you said sine, opposite, and hypotenuse. So I'm going to say sine of 36 is equal to the opposite, which is x, over the hypotenuse. So again, just multiplying both sides by 10. What do you get for your x value? Okay, you should have gotten x to equal 5 point, again, I'm leaving lots of decimal places here, 8, let's go 878. Okay, so now that's x, but remember that's not really what we're not done yet with that. All that is this little piece here. So think about what you got to do with that to end up at your perimeter. Well, I'm going to take it, and first thing I need to do is double it so I can get this full length. And then I'm going to have to take it times 5 because I have 5 sides total, and that's going to get my perimeter for me. All right, so if I'm going to take it times 2 and then times 5, I could just take it times 10. That would work. And the perimeter then ends up being 58 point, again, I'm going to go several decimal places here. All right, and then I'm going to grab that number there, that perimeter, and that's going to go in for P. So let's finish out our formula then. The area is equal to 1/2. The apothem was 8.09. And the perimeter is 58.779. You know MathXL is picky about their decimal places, so leave as many there as you can, and then at the very end, we will round to what they tell us to round to. What do you think the area should be on this problem? All right, I got the area to equal 237 point, I think it probably says round to the 10th, so I'm going to go 0.8 for my area measurement. All right, so this is a little bit more tedious. It makes you appreciate, I guess, those special right triangles that you can do in your head. On these, we have to actually like do a whole bunch of trig, and that definitely takes more time. Plus, they gave us the radius on that 10. That we had to work hard on that one. Let's try some easier ones, maybe. Okay, so let's look at this one. I'm going to start all over. Let's look at how many sides. 1, 2, 3, 4, 5, 6. Okay, this is an octagon. All right, so I'm going to do the same thing I did before. I'm going to find the central angle. So if I draw that radius and this radius, I know that there would be 8 of those blue triangles in there. So I'm going to do 360 divided by 8. Okay, so that's 45. But then when I drop the apothem to create this other triangle, it's only half that. So that angle right there, after I drop the apothem, should be what? Okay, 45 divided by 2 should be a 22.5. Not a very pretty angle there, but that's okay. Now, if you look at what we're shooting for, we want to find the area, so I know I'm using my 1/2 AP formula. I'm in luck here because they actually gave us the apothem. So it's 1/2 times 4. My goal is to figure out the perimeter then. Well, the perimeter is going to come from these side measurements. So if I can figure out this measurement right here on this little triangle, then I'd be able to work my way to the perimeter. So I'm going to redraw that triangle, kind of clean it up a little bit. So the angle I know is 22.5. This straight leg, this apothem is 4, and I'm looking for this side over here. So using your SOHCAHTOA, do you think that that's sine, cosine, or tangent? All right, so from the 22.5, you've got the adjacent side, and you're looking for the opposite. That should be tangent of 22.5 is equal to opposite over adjacent. Multiply both sides by 4. Tell me what your x equals. All right, I have a 1 point, again, leave plenty of decimal places, 1.657. Now, but we're not done with that because that's only this little piece here. So now, just like last time, you got to double it to get the whole side. And then on this one, it looks like we got to take it times 8 because there's 8 of those sides. So I'm going to double it, so times 2 and then times 8. Okay, so the perimeter I have is 26.51, I guess is a good clean spot. Let's go ahead and grab that perimeter. Let's plug it into the formula up here, and then tell me what you get for the area. What's the area of this? All right, I got a 53 point, oh gosh, I don't know, rounded to the nearest tenth is really just still 0.0, 53.0 for the area of that octagon. Okay, let's practice one more. Oh my, what's this thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a decagon. Okay, so on the decagon, I'm going back to my 1/2 AP. They were not as nice to hand me the Apothem, but they did give me a side length. And if a side is 6, I could pretty quickly go find the perimeter on that. What I don't have is the Apothem. So let's go ahead and draw the little triangle. Let's see if we can figure this out. You start off and you draw what we call the central angle. You draw in those 2 radii. There would be 10 of these triangles that I could draw in there. So I'm going to take 360 and divide it by 10. I can do that in my head. That's 36. But then when I drop the Apothem, now the triangle measurement is going to be, or the angle measurement, there's going to be half of that. So that angle is an 18-degree angle. Okay, so I'm going to grab this. I really don't need, I guess I'm just going to erase the, oh, I didn't mean to erase all that. Okay, so let's go draw that in. I really only need this triangle here, right? And here's your right angle, and I've got, that's an 18. Now, what other measurement on this triangle do we know? Do you know your Apothem? Do you know this little leg, or do you know the hypotenuse on that thing? All right. What we were given was that the whole side length is 6, so this little piece would be half of that. That little side length would be a 3. All right, what I'm looking for so that I can use my formula is this Apothem right here. I'll call it A. So now we are going to be using the 18 degrees. The side opposite is 3, and the adjacent is the A. Opposite and adjacent would be tangent. So tangent of 18 is equal to the opposite, which is 3, over the adjacent, which is A. All right, this is that trig problem that takes a little bit more work because now I have to multiply both sides by A. But that does not isolate it. All it does is get rid of the fraction. So now I have A times the tangent of 18 equals 3. So on this type of a scenario, you're going to be dividing. So go ahead and type that in your calculator. Tell me what you get A to equal. All right, I have a 9.233. That's your Apothem. Okay, let's grab that Apothem and let's go plug it in up in our formula. The area of the decagon is equal to 1/2 the Apothem, which is 9.233, times the perimeter. Okay, let's see if we can figure the perimeter out. This side is 6, but there's 10 sides. So the perimeter should be 60. All right, go figure out what the area of this thing is. All right, I have a 276.99. Oh, well, again, if I'm rounding to the nearest tenth, that actually would round to 277.0 is how that would round to the nearest tenth. All right, that's all I have for you today. So go give some of these a try. Look at your assignment and get used to doing some SOAPTOA.